All right, class, in this section we're going to take a look at permutations and combinations, which is section 12.3 in your textbook. And first of all, a permutation is the number of arrangements that we can have of objects in a straight line. It also will be looking like a factorial in a moment. So it's just the number of ways that we can rearrange a set. So let's take a look at, so this is we're going to use this definition of P and R. So here we've got how many permutations are there of the letters A, B, C, and D. So it says write the answer using P and R notation. So what this means is we're going to be taking, I think I actually have it where I can click it. Here we have, there's 4 different things. There's A, B, C, and D. Well, the first letter we're selecting if we're rearranging them, there's 4 different possibilities. Second letter, there's 3 different possibilities. The third letter, there's 2 different possibilities. And the fourth, there is only 1 possibility. So that means there's 4 times 3 times 2 times 1. There's 24 different permutations, or we talked about last lesson, there's 24 different ways that you can do this rearrangement of A, B, C, and D. The difference is now that we're just calling this the word permutation, and it is just talking about how many different ways, this is talking about order, how many different ways can you order these 4 letters. And so to write it in this notation, all we have to do is just figure out how many, the N is how many things there actually are in the set, and then R is the number of objects that you're selecting. Okay. So in this case, there are 4 different numbers, and we're taking the whole group 4 at a time. So we're not taking 1 at a time, we're taking the whole group of them. So it's 4, 4. So again, there's 4 objects, taking the whole group 4 at a time, and then you put a P in front. That's all that this means. That's all that it asks you to do in the lab also. Okay, so how many permutations of the letters A, B, C, D, E, F, and G are there if we take them 3 at a time? So it says write the answer in P and R notation. So here there are 7 different letters, and you're taking 3 of them at a time, and the answer is 210, and we'll talk about why in a moment. We're going to get a formula for this. Here, the easiest way that you can do it is, well, you're going to have a button on a calculator that you can actually do this with, but the actual way to work this problem out is that there are 7 different letters, and you're only taking 3 at a time. So that means you're only saying I've got first position, second position, third position. In the first position, I can take 7 different letters. Second position, there's only 6 left because I already took 1. And third position, there's only 5 left to choose from because I already chose 2. So you're just multiplying 7 times 6 times 5 with the fundamental counting principle from last lesson, and you get 210. That's what this permutation 3 at a time is meaning. And we'll learn how to do this on our calculator after I show us the formula in a moment here. So, factorials. Factorial is a very important concept, and you'll see here there's exclamation marks, and that is dealing with factorial notation. And so we use factorial notation when you've got P and R permutation notation. Anyway, so what this means is you take whatever number you've got, the N, and you write it out so that it's the next consecutive number, the next number in consecutive after that one, and so on. It's easy if I just show you like this. I have 6 factorial, and so we have 6, and then the next smaller number, you multiply by that, which is 5, and then you keep working yourself all the way down until you get to 1. So 5 times 4 times 3 times 2 times 1. This is what 6 factorial means. So 6 factorial means specifically to write the numbers out in a list like this that are all consecutively smaller, all the way down to 1, and then actually multiply it out. You should have a button on your calculator. It might be in a probability menu. You might see PRB on your calculator or something like that, or you might just see the exclamation mark. If you have it, just push 6 and then push that button, and then push equals. On my calculator, I push 6, and I have to go to a math menu, and then I have a probability menu, and then I have factorial, and then I get 720. All individual calculators are going to vary, but the answer is 720 if you multiply it out. If you don't have this button on your calculator, then just multiply it out this way, and it will do what you want. Now here we've got 6 minus 3 factorial, and so now on this one, or sorry, 6, I said 6. I meant 8. 8 minus 3 factorial. Here it's just like order of operations. You don't do 8 factorial minus 3 factorial. You do the 8 minus 3 first, and you get 5, and then do the factorial. So now in your calculator you can do that. 5 factorial is going to give you 120, because this is just 5 times 4 times 3 times 2 times 1 is 5 factorial. And your calculator will tell you it's 120, or you can multiply it out by hand and also get 120. Now this is a little different. We've got 9 factorial divided by 5 factorial. And what's going on here, I'm going to erase my slide, is that this is a little bit different. If I write this out, this is 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial is equal to this stuff right here. So what you can do whenever you have a division problem is you actually want to set it up so that you can cancel. And I would have actually wrote it out a little bit different if this wasn't my first time explaining it to you. I would write 9 times 8 times 7 times 6 times 5 factorial and leave it like that, and then put it over 5 factorial. And then I would cancel out my 5 factorials. I'm going to do the same thing over here. I'm going to cancel all this out with this. So really all this problem turns into is 9 times 8 times 7 times 6. And then you actually multiply that out, 9 times 8 times 7 times 6, and that gives you 30,024. Now you can actually still do this on your calculator. If you just take a 9 factorial and divide it by 5 factorial, you get the same answer of 3,024. But this is just a canceling way that will help us do some math in a couple moments. But this does some similar things. We've got 8 factorial, so I'm going to work it out to be 8 times 7 times 6 times 5 factorial over 5 factorial 3 factorial. And I'm going to show you how the canceling helps us here. I can change colors. There we go. So 5 factorial, cancel out with a 5 factorial, and I'm left with 8 times 7 times 6. And on the bottom you have 3 factorial. I'm going to go ahead and write that out. 3 times 2 times 1. The reason why I write that out is because 6 is 3 times 2. These I can cancel, or just 3 factorial is 6. But now I'm only left with 8 times 7 over 1, which is just 8 times 7. And 8 times 7 is 56. And that's how we can simplify with factorials. Okay. There we go. So now we've got our formula, finally, for permutations. And that takes, now that we know a factorial, we take our number that we're so if I've got 8 things and I'm picking 3 at a time, what you do is you just plug it in, so it's 8 factorial over 8 minus 3 factorial. And so in this particular problem, I would have 8 factorial over 5 factorial. And that would be the same answer that I would get if I multiplied, or if I just worked out 8 times 7 times 6, because there's 3 locations and I'm selecting 8 things. And that's how this math works out. We have 8 times 7 times 6 times 5 factorial divided by 5 factorial. Those cancel. So we're left with 8 times 7 times 6. All right, so here we go. Permutations. All about order, because we're going to get a new thing in a moment that's not caring about order. But we've got a 12-person community theater. They produce a yearly musical. Club members select 1 person from a group to direct the play, a 2nd to supervise the music, and a 3rd to handle publicity, tickets, and other administrative details. How many ways can the group fill these positions? Well, we've got 12 people, and we've got 3 different jobs. So we've got, let me just make sure that was 3 different jobs. We got director, 2nd to supervise, and 3rd person, yes. So there's 3 people. So basically what we have is a permutation of 12 people, but we're only taking 3 at a time. Now it's a permutation because we care about them in a particular role, a position. Because we care about position, it is talking about order. So really this is saying I need 12 times 11 times 10. Or if you use the formula, it's 12 factorial over 12 minus 3 factorial. And that would give us 12 factorial over 12 minus 3 is 9 factorial. And then that turns into 12 times 11 times 10 times 9 factorial, and the 9 factorials cancel. And so either way, you got 12 times 11 times 10. Here we got 12 times 11 times 10. And if I do that on my calculator, 12 times 11 times 10, I get 1,320. Now you have a button on your calculator that should say, if you have a calculator at Scientific, it should say NP, oops, that's supposed to be a P, PR. If you have an NPR, the way that this goes is you type the first number, which is 12. So I type 12 on my calculator. Then I push this button, and then on my calculator it'll say NPR. Why am I writing P's like that? There we go, PR. And then I push the 3 after that. My calculator screen looks like this, and when I push enter, it just gives me the 1,320. So it's a very useful tool if I have this button on your calculator, and then you just type it in the order that it is in the parentheses. You type the first number, then push the button, then type the second number, and it will give you the final answer without doing all this longhand work. Okay. Now the next step that we need to talk about is combination, and this is the way to count the amount of ways to group a set. So it's not the ways to arrange it, it's the ways to group it. And what happens here is we get a little bit different formula. Basically what you do is you take the formula that we just had for combinations and we're dividing by an extra r factorial because we're not interested in the order of the objects, we're just interested in the size of the groups. So how many 3-element sets can be chosen from a set of 5 objects? So basically I got 1, 2, 3, 4, 5. The situation is I want to say, all right, how many groups of 3 can I make? Well, I can make one group here, make another group. You can just keep circling and figure it out. But the short way of doing it is just saying, well, it's just 5 factorial over 5 minus 3 factorial times another 3 factorial. And this makes my work to become 5 factorial over 2 factorial times 3 factorial. So again, notice what I did was this is really a combination of 5, 3, where this number is the n, this number is the r. Okay, so if you did it on your calculator, you would just say 5 NCR and then push 3, and it's going to give you the answer that I would get over here, which is 5 factorial. Sorry, 5 times 4 times 3 factorial over 2 factorial, 3 factorial. 3 factorials cancel. 2 factorial is just 2 times 1, which is 2. So this is going to reduce with a 4 to become a 2. So really the answer is 10. And if you do it on your calculator, 5 NCR 3, you also get 10. So what that means is there's 10 different ways that I could group 3 people amongst the set of 5 people. 5 objects, I guess. Okay. So back problem, sorry. It says how many 4-person committees can be formed from a set of 10 people. And so here we've got 10 people is the n, 4 people is the size of the group. And so you can just type this in your calculator, 10 NCR 4. And if I do that, 10 NCR 4, that gives me 210. And if I set it up using the formula, you just do your 10 factorial, 4 factorial on the bottom, and then 10 minus 4 factorial will also give you the 210. Okay, so now let's say we're playing poker, and you got 5 cards being drawn from the standard 52 card deck. How many different poker hands are possible? Well, a poker hand, it doesn't say the actual, what particular type of hand you're looking for. It's just how many hands are possible at all. So what that means is you're taking 52 cards, and you're taking groups of 5. So how many ways are there to do that? You've got a combination problem. Notice they're not ordering them, so it's not like it's not talking about a particular order of the numbers or cards that you're getting. It's just saying a group of 5. And so that means we're doing combination, not permutation. And here we've got, if I type it on my calculator, it's just 52 NCR 5. Or if I do the formula, it's 52 factorial over 52 minus 5 factorial times 5 factorial. Okay, and either way you do it, calculator will work it out for you. And then if I actually type it in 52 NCR and then 5, it gives me a lot of different hands for poker. So 2, 5, 9, 8, 9, 6, 0. So 2,598,000 different hands that I could get in poker, potentially. Okay, let's take a look at the next game. We've got bridge. Consists of 13 cards from the 52 card deck. How many different bridge hands are there? Again, it's not talking about how good or bad the hand is, just how many different hands can you have. So it's 52, and then you're taking groups of 13. We don't care about order, so it's a combination, not a permutation. So I can type it again right back in my calculator, or it's 52 factorial over 52 minus 13 factorial, and then times the 13 factorial again on the bottom. And if I do it on my calculator, it's 52 NCR and then 13, which is how I'm going to do it. Oops. 52 NCR 13, and that gives me a very large number. I've got 635,013,559,600. Jeez, 635 billion different hands that you can have in bridge. Nice, very large. So, the Division of Student Services at your school is selecting 2 men and 2 women to attend a leadership conference in Honolulu, Hawaii. I would like to go. If 10 men and 9 women are qualified for the conference, in how many different ways can the management make its decision? So 2 men and 2 women to attend the conference. So here what you're wanting to do is we're going to actually throw in the fundamental counting principle, because there's 2 men and then 2 women that are going to be drawn. So we're going to end up multiplying at the end. But it's not just 2 times 2. It's not just 4 different ways, because in this 2 there are 10 men to choose from, and you're choosing 2 of them. And then here, there's 9 different women, and you're choosing 2 of them. So this is a combination, because we're not talking about order that we're picking, and we don't care about different ways that we can order the people. We're just talking about a group size of 2 men out of the 10 and 2 women out of the 9. So that means we've got to figure out how many different ways can we group the men, figure out how many different ways that we can group the women, and then multiply there. Okay, so we're not actually multiplying 2 times 2, we're multiplying a larger number. And if I do this on my calculator, it would be the same thing as multiplying using the formula. So 10 factorial over 10 minus 2 factorial, and then times 2 factorial here. Figure out that answer, and you're going to do, on the other side, 9 factorial over 9 minus 2 factorial times 2 factorial. And so on your calculator, it's just 10 NCR 2, and find out that answer, which we will in a second, and then 9 NCR 2, find out that answer. Here we go. So 10 NCR 2, we get 45, and then multiply that by 9 NCR 2, we get 36, and if we multiply that by our 45, we get 1,620 different ways that we can make this decision with our group sizes. All right, and here it is again. Let me erase that, so if you want to take a look, you can read that. All right. Assume that you and your 15 friends have formed a company called Net Media, internet music video provider. Committee consists of a president, vice president, and 3-member executive board that will govern the company. And how many different ways can this committee be formed? Now, the key here is in how many ways means we're doing either a permutation or a combination. The thing that tells us whether or not we're doing either one is whether or not we're caring about position or order. Well, as soon as we talk about president, vice president, and 3-member executive board, we've got positions. And so here we're talking about positions, okay? But there's also certain parts. There's the president, vice president is caring about order, but then we've got the 3-member executive board, which is just a group of 3. So we've got 2 different parts to worry about here. So let's actually take a look at how to work this problem. We've got to talk about how many different ways we have to choose the president, the vice president, and then out of the remaining 3 executive members. So it does change us after we select our president, vice president, because we're not going to reselect them to be on the 3-member executive board. So here is how we're going to do this. We've got 16 original people, and then we're choosing 2 of them. And then here, we've got 14 leftovers, and we're going to select 3 of them. So let's break this down a little bit more. Here, to select our president, vice president, we've got 15 people, and we're going to do a permutation, trying to select 2. So we care about order. Here we have our remaining members. Well, we just selected 2 of them up here, so now there's only, senior order friends. Why do we have 16 down here? Assume that you, you and your 15 friends, so 15 is actually 16. So there's 16 people here, including ourselves, and then we're selecting 2, and then we have 14 people left over because we just took 2 people out of the whole group, and then we're going to select another 3 of them. But this time we do a combination because we're not giving specific roles, we're just putting them on a board. So now what we do is we figure out this number on a calculator, figure out this number on a calculator, multiply those together, and we're going to get 87,360. So if you want to do it the longhand way, it's 16 factorial over 16 minus 3 factorial times, not times 3 on that time, sorry. And then over here we have 14 factorial over 14 minus 3 factorial. I'm sorry, I put 3 here, it's supposed to be 2. And then times our 3 factorial on the bottom. Now, the reason why we didn't multiply again on the bottom by the 2 is because this is a permutation and it doesn't divide out the extra r. You only do it once. And then over here, you do divide out the extra r. So on my calculator, if I just do 16 NPR 2, I get 240. And then the 14 NCR 3 gives me 364. And if I multiply that by the 240, I get 87,360 as it was sitting there for me. Okay, so that's it for this section. If you have any problem-specific questions, please email me with the Ask My Instructor feature.